for this video, the last video of foundation, make sure you have a look through Venn diagrams that we did a while ago. But in those videos, we used the Venn diagram to represent numbers in a population. For instance, we had one of the circles representing 5 people, another circle representing 4 people, and then 6 people outside the circles. We can actually use those circles and the whole diagram to represent probability, and luckily it's pretty much the same thing. So let's have a look at an example here. We've got 20 people, 4 have red hats, which is the circle A, and 6 have blue hats, the circle B. So 4 of 20 are in A, 6 of 20 are in B, and then we can quickly work out how many are outside the circle because there's 20 altogether. If we take away the 6 and the 4, that means 10 must be outside of the circles, inside the white area by here, if you like. But we can change these into probabilities. If I randomly took a person from here, the chances of me taking somebody with a red hat, the circle A, is 4 in 20. There are 20 people altogether, and 4 of them have the outcome of having a red hat. So 4 divided by 20 is 0.2. The chances of having a blue-hatted person, there are 6 people that make that terms. So 6 have blue, and there are 20 altogether, so 6 divided by 20 is 0.3. And then the probability of somebody not liking both of them, there are 10 altogether that don't like both or don't have both. We divide it by the 20, all the people altogether, and that gives us 0.5. So now we've got these in relation to probability, what they represent. We can look at this and say, well, what's the probability of somebody having a red or a blue hat? Well, we know the probability having a red hat is 0.3, and the probability of having a blue hat is 0.2. So if we add those together, because we know in probability or means add, the probability of having a red or a blue hat is 0.5, which makes sense then, because you either have a red hat or a blue hat, or you have nothing. So the 0.5 and the 0.5 should add up to be 1, everything. The probability of liking red and blue, let's say it's 0.1. We can't work it out from the figures that we've got here, but what if the probability of liking red and blue is 0.1? We can put that in the section in the middle. Then from our laws of the Venn diagrams, we know that this full circle has to be equal to 0.3, but this part of it is equal to 0.1. So the part by here that doesn't include the middle part must be 0.3 take away 0.1, 0.2. So that the whole circle altogether, the part out by here that represents 0.2 and the part in the middle that represents 0.1, those two added together is still 0.3. Similarly, on the other side, we know that the whole circle has to represent 0.2. So if we take away the 0.1 that we've just put in, we know that the probability of getting the blue hat on its own, or the person having it on its own, is now 0.1 because we took away 0.1 from 0.2. So how many people just like the red hats? Well, we know that the probability of having somebody that just likes the red hats is 0.1. So we multiply it by 20 to give 2, and that should be just like blue hats, sorry. How many just like red hats? That should be. The probability of a person liking it is 0.2, so 0.2 times 20 is 4. 4 people should know that. And then how many people wear both colours? Well, the probability of somebody liking both is 0.1, so we multiply that by 20 to give us 2. Well, that's the last a video on foundation maths, our Venn diagrams and probability. If there's anything you're stuck on, give me a message and I'll create a new video on it. Otherwise, I'll be creating a few higher tier ones each week. And good luck with your exams.